Okay, we are live. Hello everyone, welcome to our third week's AWS Reinvent takeaways and recap. I welcome everyone here on the screen and also all the people who are waiting in live for this session. And I also welcome people who will be watching this later offline. We already did a 2-week series of AWS Reinvent, and this is going to be the last week of AWS Reinvent. And then we thought we'll again summarize and recap, follow the same tradition. So here we are. So we'll just go through a round table here. My name is Narayanan, known as Narayan Krish in social network. At Narayan Krish is my handle everywhere. You can connect with me in any of these social handle. I am also part of Drive Bytes, Chennai Tech Radar. We conduct lots of continuous meetups, events. We also publish lots of videos around cloud technologies, Kubernetes, and recently we are also covering AWS Reinvent sessions, so that even if you are missing AWS Reinvent, the whole sessions, we know there are lots of tracks and sessions going on. We are here to summarize. So this is Narayanan, handing over to Rajesh.
Yeah, thanks, Narayan. And hey, everyone, welcome to Drive Bytes. And like Narayan gave a quick introduction, this is the final week of Reinvent 2020 we'll be covering. We are also planning to do a complete summary video kind where we just list out all the new launches in Reinvent 2020 and what are all the exciting features. So if you haven't subscribed to the channel, subscribe and click that bell icon so that you get notified as soon as we publish the videos. And yeah, I'm eager to start the session, and I hand over to Shiva.
Hey everyone, this is Shiva here. It has been exciting 2 weeks of discussing AWS reInvent. For a change, let me introduce myself with the future of AWS reInvent that was announced this week. This is about the well-architected framework, and then the well-architected framework is now API compatible. What it means is plug it anywhere and then start using it. We'll discuss a little bit more about this. That's the key announcement that came this week. Looking forward to interact with all of you and happy holiday season going ahead.
Yeah, hi, this is Ravi here. Welcome everyone. Now we are going to look about the AWS Reinvent Week 3 takeaways. And at the end of the session, we are going to summarize the whole thing. Don't miss this. Thank you. Let's get into the session.
Okay, we'll start with the keynote as usual. Handing over to Rajesh for his summarized view of the keynotes.
Sure, Narayan. So as we mentioned a couple of times earlier, so this is the final keynote session of reInvent 2020. This was presided by Dr. Werner Vogels. So people who don't know Vogels, so he's CTO of Amazon.com. So this time, Werner Vogels' keynote was a bit different because he was handling this keynote from some inside of the factory where we could relate all the infrastructure related in that factory to what are all the infrastructure that we have on AWS. He was trying to draw some parallels. The thinking was good, and did had some good sessions to recover. So the first one is there was this short demo about Eva app. For those who don't know, Eva is all about women's health app where they constantly monitor women's, health, heartbeat, and blood pressure, all functionalities and everything. And they were excessively, pointing out how machine learning helped them, in achieving whatever that they were trying to do. So it was a very good session, and there were a lot of technical aspects to that as to what they are doing there and how everything falls into the picture. So that was the first introductory part of that keynote. And the second one, the AWS Cloud Shell. So as a person who have just completed GCP certification, I could not be more happier than this announcement because GCP had this cool Cloud Shell, and now AWS are also have introduced this Cloud Shell concept. So Cloud Shell is nothing but it's like AWS will give you a small terminal for you, which already has AWS CLI and other CDKs which are pre-installed, so that you can just go around and type in your CLI commands and start working with AWS and start interacting with AWS resources and everything. So this is a very cool feature. It was long pending one as far as AWS is concerned, and it was really a great announcement when Virgil's introduced it.
Cloud Shell, of course, is a no cost offering, no additional cost offering as
Exactly.
announced it. So just for AWS only people who are not familiar with GCP, it's a no cost offering. The second thing is it's just like launching your Linux CLI, and on the Linux CLI, which will allow you to upload a limit. I think it's 1 GB limit if I'm not wrong, or 10 GB. I've not kept in track of it.
1
Just
GB.
like you can have your 1 GB, yeah, you can have your local scripts written, upload it to the Cloud Shell, and then start using it like, and it's region compatible, multi-region. Think of uploading scripts from your laptop into any region. Otherwise, how this would be achieved is maybe use a Bastion host, transfer files, play with it. Almost all those pains could be eliminated just by using AWS Cloud Shell. Definitely a welcome future for people who are backporting from GCP like Rajesh, definitely.
Yeah, talking about Cloud Shell, I normally follow Corey Quinn. He's known as Quinny in Twitter. So he was making joke of this Cloud Shell announcement because he was always comparing AWS is like 5 years behind GCP when it comes to technologies and releases, and he told Cloud Shell is like for a long time in GCP. And then people also mentioned about Azure is already having it, IBM Cloud is already having it. Another funny part is everybody is naming it as Cloud Shell, some with Cloud Space Shell and some with Cloud Shell. So it's going to be it's an interesting topic. Like everybody owns it, but I think it's very important, irrespective of whether other cloud providers are having it or not. I think it's important to have something like that quickly to spun up something, to do some kind of the checks rather than spinning up your own virtual VM in your local box. Straining your laptop to do some basic Linux checks, or try installing some small modules or small packages to check something. I think it's very interesting one to have the Cloud Shell. But just that I wanted to quote that about what's going on around in the world when it comes to introducing Cloud Shell, which is already there in other cloud providers.
Looks like everyone is excited about the Cloud Shell, and they were finally happy that it had made its place in AWS.
Yeah.
Yeah. Now, if we go to the next update in the keynote, there was this serverless session by Lego. As you can know, I guess Narayan actually covered a similar session in the first week of reInvent, where Lego are extensively using serverless in their e-commerce platform, and how they were able to leverage most of the benefits from that. So that was indeed very helpful. And the next exciting one
Lego.
is
Sorry, I could join you guys late. Hi, Rajesh. Hello, everyone. Yeah,
Yeah.
one interesting part of Naren's discussion last time again, and today, this week's AWS again, they were talking about how in 2018 they started looking into microservices, and the way Lego can spin this story just before the COVID situation, and everything, they made it like a very stable platform. The way monolith to microservices journey, which made them to free up the engineers to start working on the innovative work. That's one good takeaway from the Lego story, which we were closely monitoring. People think that the microservices, getting into microservices world would take little time, but the journey is worth, because you can free up a lot of engineers work to do innovation. If somebody is looking towards a microservices world, I think it's a good story to look at what happened in the Lego world. Thank you, Rajesh, for covering that.
sure. And next, the most awaited one announcement is about the fault injection simulator. So this is a fully managed chaos engineering service. So just last week, again, we covered this topic, like how Amazon Prime Video, they purposely bring down their production systems so that they can test all this everything. So this is really again a particularly very good managed services AWS has just offered, because uh, I don't know whoever is covering that, but recently they included this chaos engineering also into the well architected framework. So definitely we have to, like, whoever we architects or anyone who are going forward with AWS, we have to consider that going forward we should definitely make use of this fault injection simulator, which is a absolute chaos engineering service. We also have a session on that which we will be covering in the future slides. Any some words, Shiva?
Yeah. Chaos engineering is something very close to me. I was working in last for almost a year now on trying to implement, like we are almost success in implementing chaos engineering in our current organization. But of course not using AWS fault injection simulator, but we used open source chaos toolkit for it. It has lots of features, but the overall chaos engineering principle itself is very interesting, right? I think Netflix is more an eye opener. I would say more an ambassador for this concept for a very long time now. Rather than testing our systems, which was in the traditional way, checking for a particular functionality is working or not, checking whether a particular issue is fixed or not, testing it with the point of view of finding bugs, right? Once the system grew like thousands and tens and thousands of containers, it's going to be very, very hard checking every functionality that we have. Even if you want to run a complete regression suite, imagine the number of hours, days, months it can take to complete it, right? The chaos engine comes in handy to really reflect what happens when in a production system, right? In production system, not all use cases are executed in a sequence in a particular way. Not all systems or applications or hardware or infrastructure goes on in a particular way. There is no common pattern to it, right? It's all very chaotic, and that's the reality. That's the way nature works. So chaos engineering principles applies in the same way. So we go disturb the system randomly, but of course in a controlled fashion. When you say controlled, we are controlling it into a time and resources point of view, meaning it's well informed duration when we are going to create this chaos so that people are available, and then you know a set of series of chaos that you are going to introduce, so you know which system or what is the blast radius you are looking at. That way it's more controlled. At the same time, it's random. So you will not say this is a node I am going to delete to somebody, right? You will go delete a random node. Just one example. So that way you are actually trying to emulate what happens in production and make sure how people react. So there are multiple learnings you can take when you do a chaos game day or an event where you want to execute these chaos experiments. One thing is of course testing the resilience of the system, right, itself, and also introducing the outage when everybody is available. The third important takeaway is how are people reacting to it, right? When such an outage happens, how are people reacting? How we are really resolving? What are different gaps that we have in the overall incident management flow, right? All this will be able to identify during this practice. So it's very, very interesting topic. We can talk in a separate session for this. I'm already having in my head to have a separate video, a detailed video around chaos engineering. Of course, followed with examples and then trying to implement some of the scenarios. And with AWS having it now, why not use that one also to do a good demo around it? It's very, very interesting topic. We can keep talking, but I would consider moving to the next topic so that we can come back to this when we have time at the end. Otherwise, of course, we have a dedicated session. So if you have not subscribed to the channel, subscribe and give a thumbs up to this video if you like the way we are summarizing it. That way we'll be able to provide much more videos like this in upcoming weeks, months. Thanks.
Talking about
one thing. Go ahead, Shiva.
You first, yeah.
Okay. Okay. One thing which normally people try to train the system is they wait for their application to little stable, and then because this is chaos engineering is something they feel that once the system is up and running, and then let's start looking into the other opportunities to bring in the chaos monkeys or any of the framework to try with. I think if we have it in the beginning, like a service, what the way AWS has made it now, it's a good news for many companies. They should start looking from the requirements management point of view. From that day, they know that they can start doing chaos engineering. They don't have to wait for the entire system to be very good, stable, and then they can experiment something, because now it is easily accessible when it's a fully managed service. So yeah, hope many people can take advantage of this one now.
Yep.
Yeah,
Coming
Shiva.
back to chaos engineering, one of the things that we tend to do during a chaos experiment is introducing a lot of changes to the environment, especially infrastructure. Let's all welcome AWS Change Manager as one of the things that was announced this week. It's a great feature that was announced. It allows you to raise changes, approve changes, manage changes. Change management is all now a part of AWS itself, and the requirement for it is having a AWS system manager in the particular region where these changes are getting executed. So let's all welcome this new feature and a relief for a lot of ITIL based companies here
Yeah,
to track changes.
definitely. A lot of compliance teams also might be looking at this.
Yeah.
Show me in this system now. Okay, cool. That's a good feature.
And yeah, next if we move to the another interesting feature that I would say, that is Amazon Managed Service for Grafana and Amazon Managed Service for Prometheus. So earlier we used to see, right, like whenever the companies they want the cool dashboards with Grafana or anything, they had to run an EC2 instance, and on top of that they install all these packages of the Grafana, and then they have to send the data to that EC2 instance. I mean, the data should flow, and they had to set up almost everything, and it was like, again, overburden of, like maintaining the underlying EC2 instance, running patches and everything. Looks like most of the customers who are at the AWS is customers, they were, like they expressed their interest of having Grafana at Prometheus, and that's what Vogels also confirmed, that they are now going to offer this Grafana and Prometheus as a managed AWS service. So like I said, it has many data sources, be it CloudWatch or from the logs which are already exported to S3, and various other data sources where it can compile everything, and it lets you form these cool dashboards so that you can have a good monitoring interface of whatever it's going, and you can create a respective alarms and other notifications for this monitoring. Yeah, this is definitely another good feature that was long pending from AWS.
Apart from supporting something like AWS TimeStream or Elasticsearch, the native services, here they also have plugins, or maybe the people can still visualize data from external sources like New Relic, like Datadog, like MongoDB, right? So these are some of the key things that help us. If somebody is just looking for a visualization tool change as a service, and the data source still resides in something like a MongoDB on-prem or MongoDB somewhere else, right? Definitely, it's a welcome feature. Less management by just managing the visualization tool here, right? So yeah, without changing the data source.
Yeah, specifically on Grafana and Prometheus, if some of you or some of your colleagues have managed Grafana and Prometheus on-prem, I think you know what I'm talking about. It's going to be a pain, and also deploying it in, if at all you're maintaining them as pods within your cluster, maintaining the volumes, making sure that the PVCs are all fine is going to be a challenge. I think with managed services provided by AWS, as we know by the history of AWS, that they know what they are doing when they say managed services, we can be rest assured that we can focus more on the functionality, like making sure that we're creating the right, pushing the right metrics to Prometheus, and then making sure they're creating the right dashboards in Grafana. I think this is very, very important step towards having managed services. But I also see again, overall in the industry around in the world, people are talking about it's little pricey for Prometheus and Grafana, the way the price has been put in place. But it's something that we need to balance between the price and the advantage that you get from these managed services. Prometheus, of course, is open source. So if you want to compare with something that's free to something that's priced, of course, it's always high. So there is no comparison between these two. But you have to compare about the pain that you should convert every effort that you put to maintain that on-prem, and then you should convert that effort into cost, and then compare that cost with the price that AWS is putting in place. And probably I think it will be more or less, it could be lesser than that, right? But this is very, very interesting. I think we should give it a try. Managed Grafana and Prometheus is a killer, rather than coming up with, rather than just focusing on their own, CloudWatch events and then providing their own dashboards. I think it's very, very good thing to extend to what is already open source, what people are already using, and providing managed services around it. I would really appreciate the move from AWS on this topic.
One thing to add there, Naren, is that people can use cloud for innovation now. Having all this, setting up a Grafana on-prem and Prometheus on-prem requires some skill for people to consider out of their work. We have to go again, try these things, and then come back. And as Naren mentioned again, they can choose this option whether to go in the cloud world or in the local, in the data center if they have enough servers. That choosing becomes much easier when you have it as a managed service. You try it now, run it for a while, see how you are getting benefit. If benefit is looking more, people don't mind spending money in cloud, or if they have enough services, enough systems running in the on-prem, they can go ahead and start using it. That's the beauty of having the managed services for sure. The innovation becomes much easier, faster, like we were talking about the chaos engineering also.
I think it's a very valid point. Same thing, in the same discussion, I've seen also people from this view that they say it's not just about using it for a long time or using it in your production system. Use this one to quickly onboard your ideas into Prometheus and Grafana and see how it's useful for your use case. If that is useful, then of course you can make a decision whether to run it on-prem or use the AWS service. But doing the first kickstart for that, instead of setting up everything on your system, doing a big POC, even setting it up, and by that time we will already drain before even getting into the functionalities of it. I think that's a very valid point, Rafiq. I see also in the industry people are talking around with this point of view, which is obviously optimistic.
While talking about Grafana and Prometheus, let's also welcome AWS Application Manager, Systems Manager, Application Manager, as they call. It reminds me of my famous old days with IBM on Tivoli with, Application Dependency and Discovery Manager. What this suite of tools will do is let you discover applications, as well as if you're on standard application delivery framework, it gives you an automated runbook based delivery to fix faults. So it's definitely something that the cloud world should look for, carrying on the fundamentals from the data center world. So let's all welcome the application systems manager, application manager, as they call it.
Yeah.
Okay, anything else on the keynote? I think it's fine to move here.
One thing which I noticed in the keynote, sorry, I did not cover the Eva part, but overall, if you look at the Eva, Brainly, Lego, and Zoom is another very good story to cover with, because during pandemic situation, all of us one or other time, either for school kids or for our own office meetings, we were one or other time using Zoom. They again tried moving into the microservices world, where they were moving the manageable components to a scalable situation, and they took AWS help. The story was very well narrated in the keynote. What we could take away is look at the scale they were going at. It looks like more than 30x faster growth they have seen during pandemic situation. The numbers were very fascinating. They were adding just 5,000, 6,000 servers in a night when they have to scale up. This is like I don't know total full architecture behind the Zoom, if they are onto the Kubernetes containers or how are they doing it, but something a good thing to start looking the way they are doing it, managing the microservices. Something we need. They are definitely on microservices. That much is been mentioned in the keynote, but adding 5,000, 6,000 servers in a night is something really a big scalable solution they have, and they were able to manage it quite well. Even this somewhere remote school teachers today, they know about Zoom because they are using it as a teacher, and the traffic is not predictable like previously the way in the before. They know that during India US time, the Zoom meeting normally it peaks. They know the peak hours, right? The people while working in office during pandemic situation is totally different. That people were unpredictable trends. They were able to manage the show very well. So that's one thing. And all the companies like Eva, Lego, Brainly, and Zoom, all of them, one or other place, they were using they were called as the data companies now because they were doing so much of data analytics behind the scenes, especially the Eva's thing. It's been called as a data company than the women's bracelet, that watch company. They were able to take out so much information, 3 million of data points in a night every day, and they were able to predict the COVID situations and all that. More than in a IT company, more than any technology company, they are more of a data companies now. All this, so that's one fascinating takeaway from keynote.
There are so many interesting things across all this whole AWS reinvent, right? And combining it with the pandemic and then we working from home, we had lots of opportunities to check multiple parallel sessions, and those are like spanning across different domains, different areas, different verticals, horizontals. I think it's seriously a very good thing. Even if there is going to be event, physical event in the future, I would suggest that we should have a parallel virtual event, and not very late on demand videos, probably as quick as today. I think it's going to really help lots of consumers like us from IT.
Yep.
Sorry, I interrupted you.
Yeah. And just to sum up the other part of the keynotes, Vojals was just speaking about the other key announcements made on the other 4 keynotes and how AWS is, bringing them all together to provide a better and good or better focus for the customer service. So it was more of that, and those are the key announcements that we saw in the previous slide. Now, actually moving to this full-fledged session, which was taken by Adrian Holmesby. So here he gave this beautiful demo of how we can use this fault injection simulator. So like we discussed earlier, this is a fully managed chaos engineering service, and it primarily consists of 4 components, which are actions, targets, experiment templates, and experiments. So actions are nothing but so whatever the action that we are planning to do, like shutting down an EC2 instance, or removing it from the load balancer, or something like that. And when we speak about the targets, on what set of resources that we are planning to do, like EC2, S3, RDS, VPC. So those are the targets that where we want to do our actions. And experiment templates are nothing but it's like a predefined template where we have this set of actions which need to be done, and in set of targets on whichever the target that needs to be done and everything. So it was like written in YAML, and it gives a clear, like step-by-step process of what to do and everything. And finally, the experiments are nothing but whatever the experiment templates we have. When we execute that, those are the experiments that get to execute on AWS services. They also have this cool dashboard where we can track what experiment is doing, what are the results and everything. So that was really a good demo on that. Naran, if you can move to the next slide, where we can see, yeah. So this is one example that he presented. Like we have this event bridge, and we can see how fault injection simulator templates are placed, and then we have this command line interface, how all gets connected to this experiment. And we have this FIS. So that is the short form they call FIS. There is a start experiment, there is a stop experiment where they want to start a stop, and the other AWS resources on which they want to like execute all of this. So that was really a good demo, and I would suggest whoever are planning to implement this to definitely go and take a look at that, so that they can still get to know more about it. And obviously we have always the documentation where we can go through more about it. So yeah, you can explore that as well. And if we move to the next slide. uh,
Rajesh, I have a question here. So are they also supporting running some kind of fault injection within your EKS cluster? Anything that they mentioned about it?
It's not very specific, like we can to this particular resource or something, but it's like a generalized template. I mean, you can run it on whichever service, I mean whichever the AWS resources that you want to run. So I guess that would include EKS cluster as well, definitely.
Okay.
Yeah.
Is it like multiple templates are available already? Are we?
Some are actually available. I mean, in the GitHub repo. I mean, whenever we can go in there and we can use them. But if we want customized ones,
Okay.
then yeah, we have to write it by ourselves. And this is the last slide where he had this list of supported fault injections that they have currently. Like we can see here, it is like it's listed
Okay.
pretty big actually, and you can also see that they are planning to still add more on this front. So yeah, definitely it's worth looking and testing. I guess it's still available in preview, but yeah, once it is general available, then like Narayan said, we can get our hands dirty by playing around with that.
Yeah, by that time we'll also make probably some videos or demos around it. I think it's interesting. It's interesting what it has already, right? As I see in terminate nodes, EKS, they only, for now, they have mentioned terminating nodes. There are lots of things when we run something inside EKS cluster, right? Introducing even DNS fault or introducing whether you can connect to other services. All these things can also be checked. So I think it's interesting. We need to keep watching this, and then we should start using it, play around it, so that we can give feedback to the community as well, right? Yeah, this is coming to the. I'm hearing echo, guys. If you can go on mute. Yeah, it's better.
Sounds
Yeah,
better.
yeah. Thank you. Anything else that you guys want to discuss on the AWS fault injection, or can we move to the next topic? Okay. So moving on to next, this is a session on building reactive systems in AWS. There's something that came in after I had a very similar discussion within my organization about proactive and reactive IT management. And then I was little curious to understand what they mean by reactive systems on AWS and what are the different things that they can support. So I started checking this, and it's actually very interesting. It's worth watching. It's presented by Sasha from. It's all provided by AWS speakers, Sasha and Michael. They were explaining how you can build a reactive application, right? So the first thing is very simple. So what they want to achieve within reactive application is responsiveness. This is a comparison of what you are doing in the traditional way of developing application. Like imagine a three-tier application with a front and back end, and then even if it's SOA based, right? Mostly using synchronous API calls. So you'll do some kind of action on the screen or in your mobile. It will hit the front end, it will hit the back end, and then it will give a response. You'll have to wait for it for the overall process. It's a synchronous activity. But that was okay, a couple of decades back, right? But right now, with the way things are growing, right now we have multiple things are going in different directions. The customer base is huge. You have lots of applications that are like mobile native, right? People are using lots of smartphones. Everything is actually digital, and then the data is like huge. Like we are not anymore dealing with some few GBs of data. Like we are already talking about terabytes, petabytes of data. So with all this in place, we cannot go ahead with the old way of working. So what they're trying to explain here is what is this system or application should really be like. So it should be responsive. Of course, nobody wants to sit on the screen for a minute or two to get a response of what they are doing, right? Even if it's a successful or a faulty response, we need a response as soon as possible so that we can move on to the other things that we want to do. And then how it's formed? It's formed using elasticity and resilience, right? Resilience, as we all know, it should be able to recover from its own fault. Even if there's a problem, the blast radius should be smaller. You should be able to come back and say, okay, I have a problem, but I cannot process this use case, but probably I can process the remaining use case and things like that. Elasticity, we all know it. That's where the cloud is shining. Like you don't know what is the load exactly, right? Your system should be able to be even if you know the load, it's going to be some kind of the minimum and the maximum is going to be huge distance. So elasticity helps in managing the cost and also not managing a huge infrastructure when you don't need it. So that's also another feature that they're talking about. The last thing is the message driven. In the last AWS Reinvent sum up in the first week, I think I also presented another session on message driven microservices patterns, right? So where we talked about all the different messaging services AWS provides to support different topics like AWS SQL, AWS PubSub based on topics, etc. Right? So here, all this together is they are calling this as a reactive application, right? Just quickly on that, then people always get confused between microservices, reactive systems. What are these things, right? Microservices, as we know, is just an architectural pattern, right? It is specifically built for improving your developer productivity so that you can independently build your modules, independently build your service and deliver it and deploy it. So there is a productivity in terms of developers, and there is a diversity that you can develop each of your microservices with different technologies, right? And then there's a fast to market because you're productive, you will be able to deliver it faster because these are different small functionalities. You can upgrade them independently. You can deploy them as many times as possible in a day, in a week, right? So that's microservices on a high level, right? It's not proposing anything else. Microservices pattern as such. But reactive system is a kind of microservice pattern. You can say it's like a subset. It still suggests you should have everything as microservices. But these two boxes represents about the elasticity that you want to put in place, responsiveness you want to put in place, so that it's reactive. It's not that you don't want systems to be like push based. It should be pull based, right? You should not say, okay, I want this activity and then wait for it to come back. Rather, you say, I want this and then forget about it, and then later you will get the response. Meanwhile, you can do something else, right? This is not a new thing, but the way they are trying to put it together is it's like a pattern you have to follow whenever you are developing an application in the modern era that we're talking about, right? Quickly summing up, what are the different things that they used? Again, this is just a simple project. They have a small demo around it, and what they used to support this. So these are different things, right? These are different topics we talk about: responsiveness, resilience, elasticity, message driven. So out of these four things, if we see responsiveness, the way they use is ECS, Elastic Container Service, right? Fargate. Combination of it gives responsiveness because they can grow easily. You don't have to worry about what is my load, how many containers I should create, what should be my infrastructure size, and all those things. They are reactive. The whole infrastructure, network, storage, everything expands automatically based on the response that you need. AWS Lambda, we know it is function as a service. You trigger it, you get a response, and it can scale like anything. It can do parallel runs. It can run across regions. So even if you're one of your availability services, availability zone is completely gone, Lambda is going to be still supporting you because it's there in other region. Things like makes it responsive. And resilience, as we know, again, Lambda, ECS, Fargate, including Kinesis data stream. That's a messaging pattern we talked about, right? Kinesis data stream, Elastic Cache, DynamoDB. If you combine all these, they become resilient because all these are across regions. They have ways to increase the shards. For example, Kinesis can increase shards accordingly. Elastic Cache can easily add additional storage that you want. It gives a caching level so that you are more resilient. Even if your actual database is down, you can still use the cache data, which will have some limited functionality, but still you will be able to manage your application, go through what's happening, right? DynamoDB, we know the way it stores and the way we retrieve. It's a document DB, and you'll be able to retrieve data much faster. Do not worry about the relational way of working. Elasticity, again, the same combination. Message driven, as we know, specific message data stream. Elastic Cache is mentioned here in message driven because they are talking about the PubSub within Elastic Cache of Redis. So this provides a PubSub pattern where you can do a publish subscribe for the data. You need not really connect to a database like in a traditional way and wait for the data to be queried and then retrieving it. tuning it, etc. There is a PubSub pattern available within Elasticache for Redis, and they were utilizing it this example, right? So imagine, so just think about it, how you can make this just by using this couple of AWS services, how you can make your reactive applications, everything in cloud, and making sure that you're matching all these QoS parameters like responsiveness, resilience, elasticity, and message to they actually took an example and then they tried to explain how these all fit together. Again, this is just a subset of what AWS provides. Of course, if you look at the overall ecosystem, there are lots of services that provides all of these or much more. But of course, based on our use case, you might have to select the right one. Right? The use case. Use case is a simple one. For example, a customer visits, you have an ad banner. He clicks the banner, and then this information goes to a product site or e-commerce site that's actually putting this ad. Right, so it's basically a different portal. They click on ad comes to your portal where they buy product. If they buy product, then the person who is advertising will pay money to the portal where you are pushing the advertisements. Right, it's a typical Google ad kind of setup, you can say. And this whole thing, nobody wants this to be very synchronous, right? Because it's just an ad. He doesn't want to be impacting the actual portal where you're putting this advertisement. So ad tech is a very good example of how where a reactive system should be built. So ad tech is it should be expanded as advertisement technology, right? So the example that they gave, again using all the services, goes something like this, right? So data ingestion comes from here. So somebody is clicking, it goes to the auto load balancer, as we know, application load balancer that again can expand. We will not worry about its availability, and it will not be a single point of failure. So we can trust the load balancing provided by ALB, again in AWS service, which goes to ECS, which is actually going to look at your data and convert it into a form so that everybody else needs it, and also adds the data from a reference data to it. For example, who is the actual advertiser, what is the price, whether you already started the payment and things like that, and then it actually enriches the data, right? This data is then pushed to Kinesis data stream. Finally, a lambda function looks into the stream, massages the data, pushes into DynamoDB. So basically, you have the data finally stored in DynamoDB. On the other end, if you see how this reference data comes in, reference data they're using Elasticache for Redis to store the data, and this also comes in a very similar fashion. Like somebody else, some system administrator is pushing the core data. It again goes via Kinesis messaging stream. Lambda function processes it, and then finally Elasticache gets stored this reference data. Then all this together acts so that this message, whatever this particular click, whatever this guy is doing, is enriched, massaged, stored, so that you can later analyze how successful your campaign, advertisement campaign is, right? So what is this? This is all disconnected. It's all asynchronous way of working, right? None of them are different. Even if something is going down, the other part is not really different. It will still work. A part of functionality will still continue to work because we are using messaging patterns everywhere, message streams everywhere. You push the data, you forget, you go ahead, do the remaining, right? Even if that particular thread is busy, Fargate will make sure there are multiple tasks getting created at the end, right? Similarly, while massaging, there are too many streams coming in, Lambda will automatically scale, create so many functions, parallelly processing if you're making sure that it's stateless, right? And then it will be able to push the data parallelly. So you need not worry about any of this. Imagine that you want to build such a thing either in your on-premise or in a single EC2 machine if you are building such an application. Imagine the way how you should support this whole scaling, because you have no idea how many people are going to click this banner, when they are going to click, when it's going to be the low peak, when there's nobody going to click, right? Then you have no idea how to provision infrastructure for this. So imagine just putting all this together, you are making the whole system reactive, and at the same time, if there is no clicks, you're not paying much, right? It's all very, very interesting. This is a very good use case. Of course, not the solution for everything else, but the learning is how you can utilize whatever is provided by AWS to build a reactive system, and that way you can make things that are asynchronous, that are loosely coupled, and able to deliver a solution. I think this is something that we should keep in the back of our head, so that when we put solutions in place in future, we can think about these combinations. That way we can make sure the system is reactive, right? Not in our traditional way. All of us are from decades, mostly decades old in IT. I think we should stop, try to flip the coin and see what are the other ways to do in the modern era. The next session that I would like to go, again, I would like to be fast here, is about the GitOps compliant, how Combank is Commonwealth Bank of Australia. They actually use GitOps pattern to make sure that everything is running in EKS, but still all compliant, because we are talking about a finance service here. It should be compliant, so it should be super secure. And they should also want to use everything that is trending, right? Now, how can you mix all these together, right? GitOps is a solution that they are talking about here. GitOps is very interesting scenario, because we were in the traditional world when somebody talks about CI/CD and then Jenkins. The way we do it, actually, we build something, we deploy it to a particular server, we roll it out, and then we check what is the status. Now, there are two disconnected things, right? You have a code somewhere, then you build something that is runtime, and then you push it, and then the runtime is versioned separately, and then your infrastructure is using this runtime version to get deployed. Right? This is a normal DevOps pattern, the normal way you do CI/CD. But what is GitOps? GitOps is you need something somewhere in between where developers can touch. So developers will drive what is there in your live infrastructure. At the same time, your live infrastructure is controlled by an immutable firewall, meaning they won't go modify the infrastructure directly, but they will modify the code, which will modify the infrastructure, right? So that's the GitOps. So you modify the code, it modifies the infrastructure, but still it's controlled so that nobody can directly go and modify the infrastructure. What is the advantage? Because of this Git being in between, you put all your compliance, you put all your validations, you put all your checks here, and the advantage you can automate all of this. That way you don't need a person to manually validate what are you releasing, whether it is compliant, whether it is secured, whether you have done enough testing before you deploying it. You don't need that kind of activity anymore, right? It's all driven based on Git. So Git is your source of truth. So if you want to know at any point of time, where is my infrastructure, what is my state of my infrastructure, go to the source code, have a look at it, right? Another thing is it's repeatable. Same thing you take, deploy, make another infrastructure if you want. If you have a downtime, go create another green stack if you want. And if somebody wants to audit, give this source code to them. They can audit everything that's there in your infrastructure. They do not go get into the live system to check what is happening, right? It's a very, very interesting topic. And this whole session was around how Commonwealth Bank of Australia really used it. So it was presented by Michael from AWS and Dario from Commonwealth. It's a very, very interesting session. I would ask everybody to go and check it also, the live session. Quickly about just one more slide about that is there is one more thing that's very interesting in their talk is about how they really use multi-cluster, multi-tenant, multi-account way of deploying EKS clusters and deploying and maintaining their application, right? It's very similar to what we discussed in Lego session that I explained, serverless, where they were trying to differentiate everything using AWS account per business unit, because they don't want one business unit to know about what other business unit doing, but still share some data that are important so that you can make consolidated reports. Here, it's the same case. They have different set of applications, and all these set of applications, they want to isolate, right? In AWS, a good way of isolating is AWS account, right? Because you have your dedicated IAM roles. You cannot share the IAM roles. Anybody wants to be in that account, they should be part of those roles that are attached to that account. And the other advantage is you can create multiple EKS clusters attached to that account, and each cluster can have multi-tenants. So they were trying to use a combination of it. If you see, what they were mentioning is for every application that they are talking about, when I say application against multiple microservices, for each application, they had 2 AWS accounts, right? And that is non-prod cluster and prod cluster, and it had multiple EKS clusters running inside, right? Again, they have 2 different ways of isolating. One isolation is at the AWS account level, so that only those people who are part of that account can really access those applications. Second isolation is at the EKS cluster level, so that people who doesn't have access to that cluster will not be able to touch the application that are running within that cluster. So that way they have very clear control over the blast radius of how the things are being put in place in production, right? They were also utilizing AWS code pipeline, code build for deploying. They are also using Argo CD, and they were also using OPA to validate your compliance, right? So the way they tell you is everything there are two parts to it. So when anybody who is checking in, it's all validated in the source code, whether it's compliant. So they build all the rules, compliance rules. It's again all in Git. That is, compliance rules are enforced whenever you are pushing it, and these rules are pushed by Outsourcing, right? And then they have the source code. The whole infrastructure is written using AWS CDK. So it's all programmatic, so they can run test cases. They can create modules. It can be used across the organizations. They can make standardization standards. They can enforce standards at two levels. Developers themselves, they have a series of checklists that they have to follow, how they have to make. Second level is at the CI/CD process, where they validate whether it's compliant with their rules that they have put in place before it getting pushed. And once it is pushed, nobody is interrupting. It goes to the Git. From Git, it goes to the infrastructure, the live production environments, right? And nobody goes and modifies the production environment ever. Even if they have to modify those, then they have to get a specific token. That's a temporary assumed role token that they have to specifically get to get access to the live environments. Nobody else go touches the live environment. They have to modify the Git repo, which is the basis for the GitOps pattern itself, right? This is a very, very interesting talk. There are so many things they discussed. I cannot get into all of them, but I think I would suggest really go to the link that I provided here. We will also share the link in the description of the video. That's very, very interesting. So anybody who is trying to build something in production using EKS, you want to follow the multi-cluster, multi-account pattern. It's a very interesting talk to see. Of course, they give also introduction about what is GitOps, which is also a very interesting topic.
Okay, I hope I'm audible now.
Yeah.
While you talked about the GitOps and reliability, resiliency kind of fundamentals, just wanted to also add a couple of announcements here from AWS reInvent. The Redshift cluster is resilient now. What it means is like we can move the Redshift clusters across the availability zones. That's one of the things. And then the second announcement that's on our way is like one of the breakthrough features for developer clouds, definitely, if not for other organizations. It's that now the member accounts can look at the cost when it comes to elasticity. Cost always plays an important aspect. How good am I doing, right? It was like the account manager that was able to see the total cost and summarize to individual members, but now each member will have that purview limited to their accounts. Right? So that's one thing, looking at the FinOps model or towards cost optimization while we thrive towards the elasticity.
Yeah, that's very, very, very interesting. Talking about FinOps, I think in the month of January, we'll try to come up with a series of videos that's going to explain about FinOps in detail. So stay tuned, join our meetup group, join our YouTube channel, subscribe to it, so that you will get those discussions. FinOps is again another interesting topic. Like GitOps, FinOps, it's all new things that people should be thinking about if you are part of DevOps, right? It's all interesting pieces, but must follow. Yeah.
Thank you for covering that, Naren. I think there are two very good aspects, Naren. The first is about the reactiveness, right? I think those who get into the cloud, they first look at worry or learn about the compute part of it. Suddenly, after some time, they'll realize that, okay, some of this we can virtualize it. Then again, now we are talking about total serverless kind of a way where they don't have to touch. It's one very good way of bringing any innovation. If they want to try, they don't have to again spin up a lot of things to try. I think that becomes again another easier POC for anybody to come up with. And to the second part of the GitOps world is, I think, especially good that you mentioned about the banking and any finance or any other company. Sometimes when you talk to them initially, people are very much skeptical about cloud. No, our application is very much different. It has some data which cannot be exposed. I doubt, because me being managing the data center, nothing can be more secure than the cloud world, than your data center. Anybody can walk into your data center and do anything. It all depends on a couple of people there, right? I think these are very more secured data centers in the cloud. So GitOps is, especially when the entire control is getting into the engineer's hand, and when you make it like a more of a GitOps thing, anything you're making modifications, it's more tracked, and it can be repeatable any day and reproducible any day, because everything you make as a configuration audit, right? That's very crucial part of the compliance thing. Anything you're making modification, developer goes into the console making modification, then there's no other intention, just that to fix the problem at that particular time. And after some time, our infrastructure and what we have it in the code and versus what you have it in your production account, is it becomes little irrelevant, and you have to reconcile one or other day. I think getting into the more of the GitOps world makes it world a much better place to for a operations guy. We know that what's written is been what you see, otherwise it's not there. So yeah, I think that's good. Argo CD also is making most of these things real time for people doing CD. Looks like the world is going to be different from now. Thank you. Definitely to watch something.
Okay, moving on.
As we are just speaking about the financial sector, right? So I have this another session. It's on Fidelity Investments, who are again a financial organization where they have been running 10,000 containers. So that title, it instantly caught me, like by surprise. Like, I mean, we are speaking about containers, and we maximum that I could think of from my experiences maybe 1,000 or like 2,000 or something. But that itself, maintaining all those things and monitoring them and getting the all the metrics and everything, it sounds a bit difficult task. But 10,000, it's really a very big number. And I was just curious as to what went behind their like process of bringing that.
Rajesh, sorry to interrupt you there.
So here you can see
ADP, there is a reinvent talk from ADP CTO in 2018. I think we were already 10,000 containers at that time across ADP, across clusters. It's very, very interesting, and we have multiple applications running in AWS for a long time. AWS on-premise, altogether, we are running more than 10,000 containers already. So if you are interested to run in such a large scale, do check our ADP careers page and then see if there are any openings, and then we are happy to welcome you.
Yes, Narayan,
yeah,
the best of the cloud worlds, if you want to see, people can join us in the ADP. And this again triggers me something back before DevOps world, right? When Flickr and Netflix started talking about 10 deployments a day was a big news in the past. Now it's like people who's not doing 10 deployments a day, they're not doing a good DevOps model. I think again, 10,000 containers will become very normal very soon.
Which is how I hope the retail services of Amazon itself will operate, I believe.
Yeah, definitely. That's massive they have to manage.
Yeah.
But again, the elasticity comes into play for the FinOps guys.
I'm looking forward to a reinvent where AWS present something like this. How are they managing their retail business across the world, multi-regions, multi-geographies, catering different kinds of users? What kind of framework they use, what kind of infrastructure they use. If they could make it a public, it would be a really good use case for e-commerce giants.
Yeah, definitely. We can check out with AWS guys also, who our TAM. We can speak to them and ask them to present something very soon.
Yeah.
So yeah, focusing back on this, coming back to this slide. So what Fidelity they tried is they have this platform strategy where you can see. Let's go from top to bottom to top. Sorry. So obviously they have this infrastructure where they run Kubernetes, ECS, and other infra EC2, and on top of that there is Kubernetes. And what they call this as a core platform features like security, auto scaling, and like the other compliance and everything. we keep talking about compliance because all this financial organizations, they are expected to be very compliant with data that they deal or handle every day. And on top of that, we can see there is the trading platform, there is an API platform, and there is an machine learning platform. So they follow this platform strategy, and they had a couple of slides as to supporting their statement as to why platform strategy helps. Because one major thing is, like I said, they are running this 10,000 containers across multi-cloud, and they had to do this cluster management. They had to auto scale the clusters as per the traffic and everything. So that's where they strongly backed this platforms. It was help them doing what they have set for themselves. And yeah, you can see it's just an overview of the architecture of what is exactly happening there. And if we move to the next slide,
Interesting thing that Rajesh described here. When we looked at the
yes,
previous architecture, I could correlate the patterns how an application architecture would look at architecting a framework versus an infrastructure architect. Infrastructure architect always goes from bottom up, and then application architect always come from, this is my application, I want logging, disaster recovery, etc., and then builds the infrastructure for it. Do watch out if we could make out some videos on the application patterns, how different architects look at different architecture patterns. We could do one series about it.
Yeah.
yeah, definitely. And like I said, like they have this multi clusters running on multi cloud. So if I move to the next slide, yeah, here you can see it's like they have custom built this K Connect. So what it does is, it's just an connection manager CLI, which helps them to connect to the Kubernetes clusters across different providers like Azure or GCP. And they uh, had this demo, like it's just a simply plugin for your enterprise credentials, where we can just connect to the clusters. And we have this quick aliases where we can set for each clusters to connect to them. And it actually, it very easily like gets integrated with the CI/CD process. So actually it was a bit like a good one, I would say, because uh, managing cluster, we had like AWS EKS Cuttle, and we have this Cube Cuttle, and all of this where we connect to the clusters. But a generalized CLI to connect to each clusters, and keeping the aliases for each of them to connect to, that was really like a good helping feature that I would definitely consider. And if I move to the next slide, here we can see, looks like this is also another one, which is Cran, which is an add-on management. I guess we recently covered about EKS add-ons, which AWS they themselves introduced during the reinvent. So again, this is a tool. Looks like they built only for this add-on management, where they introduce the concept called layers. And each layers, it helps gets shared between the multi-cloud platform. And you can see the key takeaways, like it is implemented as Skate's controller. And layers are composed of add-ons, and they have dependencies established which will be honored. So these two uh, tools that they have looks like custom built, and they have given the GitHub link as well, so that if anyone interested, they can go and have a look on that. And if we move to this last slide, yeah, again the GitOps is back. Like Narayan was covering, right? So they also follow this GitOps procedure, where each platform that in the earlier side we saw, right, there is a trading platform, there is a machine learning platform. So each platform is versioned into a Git repo, and each cluster has its own Git repository, and where it is the desired state is recorded. And when they push a specific change, so that the cluster repo, it gets detected, and the CI/CD pipeline, backend pipeline, it starts the settle, and it brings the cluster to the desired state So whatever based on the commit that we did, so we can say like how good all this, like from the beginning, like managing a multi-cluster on a multi-cloud to having those specific tools, and then finally coming to the GitOps. So we can see how everything is falling in place, and they have claimed that this has been a very bold in architecture move for them, because uh, always financial services, they had this huge traffic which they had to like face, and with proper latency issues and everything. So that was really a good session, which that was covered again on the financial perspective.
Okay, talking about this Git commit to the cluster and running a separate pipeline using EKSCTL to push this code into the infrastructure, the live environment. I think this is where the Argo CD shines, right? Argo CD natively does this. So Argo CD, all you have to specify is your Git repo, either a commit or a tag or a particular branch, and then it will be able to sync this one to your cluster using kubectl, meaning kubeconfig. So basically, Argo CD does this natively. So rather than building up a separate pipeline and then running EKS Cuttle, of course they will have their own reason why they built it that way, because they might be having some kind of additional checks or validations in their pipeline. But if this is the requirement, simplest requirement to do as Git commit towards your infrastructure, Git based GitOps, then Argo CD is something you should look. It's open source, part of CNCF, easy to use, easy to set up. It also runs inside EKS cluster. So you can deploy it as a series of pods and containers, and then you'll be able to sync your code towards the cluster, which is interesting. I ask everybody to go check Argo CD.
Let me add on with one announcement again here. It's about AWS announcing location services coming their way. Let's say a developer has to be dependent on a location service till date. If the code or the infrastructure or the application that he develops ran on Amazon, he has to be dependent on location services to a different vendor, which will give him a problem of multi-cloud first of all, and also about the usage, why and what. Now that AWS has localized this, good news for the developers who do location-based services. For example, a simple taxi app, right? So that's one thing. The second announcement, which I talked about during my introduction, is this well-architected framework, which comes with API. Just think of a system that they have explained in the announcement. Like if AWS earlier used to do it on a question and answer based pattern, now that APIs are available, a detection happens, an automatic ticketing system can come in place, track those as risks in your infrastructure, and also with the possible use of AWS Change Manager that we discussed, it can track as a ticket towards that change and close that. That completes the life cycle of the infrastructure change management itself. So a very good feature to look forward to. AWS recommended way of implementing a change management.
Definitely.
Yeah, so well-acted framework itself started as a series of documentation that you have to go through to understand. I remember doing it like a couple of years back. It's a detailed document, but you have to go through a series of pages to understand it. Then they have converted it, now looking at as API. And I've also seen a couple of products that they introduced. Probably I forgot about the names, which you will be able to use to apply this and then validate your application that's running in AWS. It will give a detailed report telling how conform you are to the AWS well architect framework. It can give you the gaps and then give suggestions across the 4 pillars that well architect framework is built around. I think it's very interesting one. Go check it. In the meantime, I'll try to look out for that particular service name. I'll let you know by end of the session.
Moving forward, this is the other interesting session that I covered. The last one will be from me for Reinvent Week 3. So we all use smart TVs at our homes, and now we have this beautiful GUI where it segregates all apps like Netflix, Prime, Disney, Hotstar, and everything. So this session was from Samsung, and obviously their smart TV services and their Plus services, and what was it like for them when they started it in the beginning, like maybe some 4 years back when they were into the smart TV business. And so that was a little background first they started with. Like you can see, their application was monolith, and they have this single massive database on-prem, and they had this database scaling issues because, as we know, Samsung operates in more than 80 or 90 countries, so they had to constantly scale based on the traffic. And this fourth point, it actually it surprised me. So they indeed tried a lift and shift model, but that seemed to be failed. Mainly they stated that it failed because of database scaling issues, and they were also not able to like have the sudden traffic spike during this global app launch. So from that background, and if we move to the next slide, you can see, like, after what are all the steps that they took to overcome these issues, that was a bit interesting. Like, so they started this AWS migration based on the cloud native architecture and microservices. So they re-architected the application into microservices, and you can still see the migration is still in progress after 4 years. I mean, you can see like how vast or how big their monolith is, and they are still trying to break it and migrate to AWS. And obviously building, like I said, all the microservices one by one. And they had this, all the REST APIs have been aiming behind the API gateway, which is another AWS managed service, and they could be able to aggregate all the applications without any changes required from the smart TV client. And like I said, the single monolith database which was sitting on on-prem Oracle, so they have shifted to MySQL, Amazon Aurora, which has this multi-region support, and they had started using this managed services, which really helped them in scaling and everything. So if you actually, the session was like like they intended to cover about how Fargate Spot was like helping them in the cost optimization front, but they gave this little background to understand a good line of thoughts, like where they started, how it's going, and how they are like adapting to all the new changes that AWS as a service provides. So it was really a good like it's like seeing a real life example of how each step an organization goes through in order to like migrate to cloud. And we move to the next slide.
Yeah, just one point here. If you see the pattern, right, all the huge organizations, the way they work is that they should first try to convert their monolith into microservices, and then not try to do a single lift and shift, which is kind of going to fail because of the huge scale that they have, and not understanding everything and then shifting it is also a challenging thing. I think splitting them two things, they understand what is there, and they also can remove things that are not used, reduce the overall infrastructure usage, reduce overall cost, reduce overall maintainability of it, right? Which was the pain that we always faced in the past with monoliths. So microservices is one bit. Second bit is around how you're going to migrate this which part of microservices will move to cloud, how you're going to manage the traffic and across the on-prem and cloud. Remember, if we had a discussion around Verizon's journey in our very first weeks of discussion of AWS Re, it has a very similar pattern, right? Move to microservices, move couple of them into a couple of microservices on the cloud, split the traffic across. Canary is the way to go. Use Canary so that some traffic is going to your microservices based new application, and then some still goes to monolith because monolith is resilient up to an extent because it was working for years now. Don't touch something that is already working. Try to split the traffic and understand your microservices in the real world. Make improvements to it. Use that as a template, and then make other microservices chunks out of your monolith based on the template, and then follow that pattern, right? So that's what the common pattern that we see across when huge organizations migrate to cloud, the first thing is microservices, move some of it, canary. I think these are all key things that everybody should remember, and it's a tried and tested pattern. And then that's the one we should start employing. And that way, it's again smaller blast radius. In case your microservice that you're deploying to cloud, couple of them are failing, then you always have a switch back mechanism to go back to your monolith till you figure out how to do it. Rather than trying to do the lift and shift, creating so many resources on the cloud, paying the cost of more than a couple of years to AWS and then realize, okay, it's not working and getting back. I think these are all good learnings. These sessions, I'm not even sure how such organizations are coming forward and actually presenting that they failed and how they. I think this is just a different era, right? I'm sure a couple of decades back, nobody talked about how their application works to outside, because even that was considered as part of their success in their business. But I see lots of openness now with respect to. Of course, they don't give you share the actual algorithm that they use. They know exactly what to hire, what to share. I think that's the openness is the one that is actually growing up in our community. It helps, and that really helps in not reinventing the wheel and reusing the patterns, learnings across the organizations, that you don't have to fail to learn something. Look at how others failed and then learn it. Imagine all these post-mortem reports that AWS and Google Cloud is sharing once they have a downtime. I'm sure a couple of decades back, nobody will know why something failed, and there is no such outburst that will happen if something goes wrong. You'll come back and check later. If it works, it works. If it's not working, not working. Right? These all are like a huge shift that's happening in this era. Happy to be part of this particular generation, I would say. And it's interesting we take these patterns and then reuse wherever we want to discuss about solutions and architectures in the future as well.
I mean, just especially
big thing. I'll let you go, Shiva, this time.
just thinking about Samsung again, right? So it's like think of the challenges that Samsung has. It has to kind of re-architect its platform, also remodel something as a part of it, and also address the modern thing requirements, like looking at artificial intelligence to check their viewership, packaging a pack so that their smart TVs are and its applications are very organized, specified to regions, specified to individual users, etc. Can't think of a better era to be in, as Narayan mentioned. It's the cloud that makes all of these things possible today. Cloud and cloud services, definitely.
Yeah, I was expecting Shiva to pitch in the moment I saw Samsung. I know this. He's not now with the Samsung, but the smart guy who moved out of this Samsung. So, not talking about the smart TV, but smart guy. Yeah, that one thing to add to Naren's discussion back again, the financial companies, right? Especially in the last slide, Rajesh was covering about Fidelity being on the GitOps with a URL, right? At some time back, any company keeping anything in the GitOps is like never can be imagined, because source control is considered something their own proprietary thing and should not go out. Even to a good large extent, ADP's Lithion also does a lot of open source contribution. Whatever we feel is something which is useful for the rest of the community, it's already there in the GitOps. So have a look at the /Lithion and the GitOps. You can see a lot of modules which are created, can be useful for a lot of the Node.js and the React kind of frameworks people are looking for forward. And one thing which Naren covered again is about models and the way companies are getting into the world, right? Lift and shift model. Definitely one thing I have seen companies who tried moving into the initial days with the lift and shift, majorly they feel they are moving to cloud because to save cost. Those who try to get into cloud to save cost will definitely fail, because cloud is not inexpensive. Unless you work it smart and make it smart to make it inexpensive. If you are taking lift and shift model, you had 100 servers here, you will be paying something to a data center. After down the line, for the same 100 servers, you will be paying more maybe. Re-architecting, getting into the microservices, slowly shifting to the cloud world is definitely something people would love to do it. They should do it in a way that they are not taking all the shit which exists in the big monolith ways, right? You don't know some of the components being there. Sometimes when companies look at the repositories or at the code, some of the monoliths which is not been deprecated, some of the functions, everything you will take it to the cloud, and again you will stuck there for very long, not knowing what needs to be taken because you will not have time. When you get a time for innovation, I think you should get smarter and try to move the components which is very important for your business value. Again, you need to look at to the units of economic, right? Then only you should try to move what is the value you are getting it and how much you can move to the cloud. Uh, Based on these calculations, I think if people move into cloud, they will see more success uh, in the cloud world. Yep.
What just Rafiq mentioned, it's up to the audience now to decide is it innovation or renovation according moving to a cloud is right. Let's
Exactly. Yeah.
We still have halfway through. I think we should try to catch up with the time. Guys, it's all interesting. We always think that we'll try to close it in an hour, but I think the way it goes, there are so many things to discuss out. So we'll try to catch up with that.
And yeah, like I said, it's just an architecture of after what Samsung has done. As you can see, there is the smart TV, which connects to CloudFront, and it connects to API Gateway, which is present on the across 6 AWS regions, and they have these applications that is running on 4 regions, and they have enabled auto scaling with ECS and Amazon Aurora, and region-aware configurations are managed by Route 53 and Spring Cloud Config. The architecture looks a bit complicated from the outside part, but it's like nothing like I said, API gateway. From API gateway, it's connected to the clusters and the load balancers of clusters, and then to the services, whichever that is running. So, like I said, it's a global. Even for Samsung, they are operating in multi-region, so they are like obliged to offer a very low latency, and they have this globally distributed across 6 AWS regions in order to handle that traffic. Yeah, if we move to the next slide, and yeah, here is where they actually compare like how their on-prem infrastructure is, and when they started to virtualize, and when they started using EKS, and finally how they moved to the serverless. And again, looks like we can't keep serverless out, so it keeps coming back. Looks like in another 2 or 3 years, most of the current trend, like whatever the hot topics like Kubernetes and containers, in another 2 3 years we'll see serverless as a key buzzword. Most of them are migrating to that, and this they had this cost comparisons, which are they claimed that it to be around 60 to 70% with Fargate Spot, to be specific, because like we discussed in our first week, it's similar to the EC2 Spot, where you can like bid for the price, and you can get much better discounts compared to the actual Fargate which is running. So yeah, definitely that's a good session, and it gives a good perspective, like how Samsung smart TVs that which are using on-prem and their journey into cloud and their migration steps, where they failed and where they want these key takeaways, so that everyone can get to that well architecture. So yeah.
Okay, this slide reminds me of our upcoming video. It will be from the upcoming session from Shiva here in the call. It will be around these topics, specifically to understand how data center, on-premise virtualization, container, and eventually serverless is actually driving the because he was there he was working in IT for several decades, and he had an opportunity working each one of these. So he'll be able to really compare being there, what it makes difference between being in each one of these. I think subscribe to the channel so that you can be part of it. I'm very interested to listen to that session because I am not part of all of these boxes, but he is. So I would like to really hear from him. So if you are also interested, do subscribe and watch out for that video.
Thanks for the advertisement, Narayan.
Always welcome.
Yeah, hi. So gateway load balancer. There is one of the interesting thing they posted in this week, and it is an add-on to the existing classic and then application in NLB. So gateway load balancer is mainly for supporting the fleet of third-party virtual appliances. So far, we are having the virtual appliances in the AZ wise or in the sandwich model, or they are deploying multiple set of firewalls within the AZ. So that's how the architecture is so far, and we are facing so many issues as such. So let us start with the challenges, and then we'll go one by one. Can you move to the next slide? Yeah. So this is what the challenge is right now. So appliance pass, like for example, whenever they want to have the IDS or IPS or any kind of third-party virtual appliances, they used to deploy it in one of the subnet, and they can't enable the active mode since the AZs are different. So either they have to deploy two set of firewalls in the single AZ with high availability, and again whether routing wise there will be a problem. You can't have multiple routes at for the same destination in the route table. You can't add any metrics as such with the VPC route tables. So we need to use some kind of scripting, and you need to detect it whenever there is a fail. It should flip, and there should be definitely there will be a downtime for some time, maybe in seconds. Now seconds is also calculative right now in the current operations. So then the sandwich deployment. So they will go with the load balancer. Again, the inbound, outbound is somehow it will help. Again, inbound it won't work. In that way, alternative way we'll be failing in at one stage, or we'll be compromising with another set of devices, either the forward proxy or the reverse proxy. Again, the misconfiguration will happen. Then the complex environment will get created with a sandwich deployment. The third one is do a DIY, do it yourself, the tooling. So each and every vendor is coming up with their own script. Either it will be inbuilt one, or they are asking the customer to write their own script. So again, there will be their own challenges mixed up with this environment as well. So to address all these, now Amazon has given the gateway load balancer. So what exactly it is happening with the gateway load balancer is the L3 gateway as well as the L4 gateway. So no need to deploy any other separate load balancer and then add some proxy kind of thing. So you can have the gateway load balancer and attach your third-party devices to the gateway load balancer, and you can point this gateway load balancer endpoint in your route table itself. Instead of creating multiple appliances or multiple ENIs, you can point it to single gateway load balancer endpoint in your route table itself. Previously, we used to have the route pointing to any of the unique of third-party appliance. Right now, you can deploy the gateway load balancer endpoint within your VPC, so that you can have an entry within your route table itself. And again, the rewriting of the packet is not going to happen here. If you have the load balancer and in the previous way, the rewriting will happen. Then it supports both the gateway and the load balancer. So the scalability is there, reliability is there, and the transparent insertion is there. So in the typical environment in the on-premise and all, we used to deploy the firewalls in the transparent mode. So you doesn't care like whether the firewall is there or the inspection is going on or what. The traffic will get a U-turn over the firewall and get it out. So in the similar way, we can deploy it through the transparent mode itself with a gateway load balancer. And then now what are the instructions we are
Like
going to? Yeah.
this looks like an interesting alternative for people who have ALB backed up with an Nginx server, for example, right? So
Yeah. Even the third-party appliance, so many vendors are trying to create multiple architectures. If you refer to take any of the vendors and you refer their architecture, each and every architecture will differ. And again, with the customer environment, it is going to differ. So whenever an engineer gets acquired to this environment, he has to understand multiple things. But with the gateway load balancer, it gets simplified. Even at the route table level, we can have a simple route within the route itself.
yeah.
That is one thing. And
Yeah,
the inspection.
while we are at it, just one thing. Shamiz, who was live with us, is thankful for the session that we have done so far, and he is also agreeing all the firms are moving towards microservices, and it's going to be the future. I like the way the community is also trending towards it. People are understanding what's happening. Thanks, Shamiz, for your feedback, and then we all agree. We are with you on this. Thanks for being here.
Yeah. Thank you, Shamir. Yeah, moving into the next slide, like what are the inspections we can have it like? Yeah. So one way around is north-south traffic inspection with IGW. So right now we no need to have the load balancer within your VPC. So you can have the load balancer endpoint deployed within your VPC and have the gateway load balancer deployed in common shared service environment or in DMZ environment, so that you can push your traffic with the help of gateway load balancer endpoint directly to the appliances. So the traffic inspection will happen through that appliance or security VPC that's on the right side. So this is how the north-south traffic inspection will happen without any transit gateway or any other thing. So no need to deploy another gateway if the environment is shorter or smaller. If at the enterprise level, definitely they are going to have the transit gateway and various other gateways to support across multiple VPCs and multiple accounts. So without that, yes, you can have it through the gateway endpoint, gateway load balancer endpoint. It's kind of a endpoint service which is already there. Like you can create the NLB and you can deploy, you can declare it as a service. Then you can enable the private link from the VPCs, so that through the private link they will reach out to that particular NLB service to get into the respective instances. So in the similar way, they have brought out the gateway load balancer endpoint as well. So you can create the endpoint within your VPC and establish a private link to your gateway load balancer service to reroute your traffic towards those instances. So
Ravi,
this is the
I
one
have
thing.
a question here.
Ravi, would you like to add what is the real use case you think?
So for example, if you are having
When do you think?
if you are going to have multiple VPCs, we used to forward the traffic through the firewall. So in the second VPC, you think about the other VPCs, not the VPCs where the network appliances are hosted. So in the other end VPC, you will create a route stating go to the peering connection or go to the VPN gateway. Again, once it reaches the VPN gateway, you can't reroute the traffic to particular appliance.
Yeah.
So the pain point is either you need to have some kind of proxy deployed under load balancer and have a private DNS name for that load balancer, so that you can enable the proxy on the respective EC2 instances to push your traffic towards your firewall. Or you need to create the individual VPN connections to each and every VPC. Then you need to reroute your traffic to the VPN gateway through reach out to the common load balancer. From there, the traffic will get into the network firewall appliances. So multiple gateways you will be, multiple instances you will be introducing, and too many connections will be established, and it will be hard to manage as well. And so many rewriting will happen. Your packet should traverse through some connection and then through proxy instance load balancer and then to proxy instance. From there, it will reach out to the local route table to reach out to the respective virtual appliance in ENI. So there is a series of components in between the transient path. Now you're going to skip those connections and those instances. You're directly pushing your traffic to gateway load balancer endpoint, and that simple load balancer endpoint is going to take your traffic till the load balancer, and it will reach out to the instances. So it's kind of transparent here, and we are going to avoid more number of devices in between.
Yeah,
Also,
that's easier troubleshooting and maintainability.
Yeah, and also we are going to reduce the number of firewalls deployment, or ultimately we are going to reduce the cost as well.
right. Lesser
I
hops
think
in the charts.
I think it will be a boon for the telecom industry, because when I was working 6 some years back with one of the telecom giants in Europe, we were discussing around software-defined networks, NFVs, network functions, and then we were talking about how we can make the components, that are appliances, that are hardware appliances, into software, and then using cloud to deploy it. We were using open network automation platform, ONAP, for deploying this. So while coming up with these appliance instances, I assume these could be like FortiGate firewalls that you have on for you, or it could be the router that you want to deploy for rolling out probably a 5G, right? So these, I think this is going to really help because of the less hops, and I think it's going to give some kind of transparency in the way the network flows, right, Ravi?
Yeah.
Otherwise, I think you will get lost after some time from where the packets are and where it is reaching, and we can no need to even talk about the troubleshooting part of it.
Yeah, even here you don't need the VPC connection itself. VPC peering connection also not required. Simply you are going to push your traffic through the endpoint. Private link will be established from the gateway load balancer endpoint to your GWLB. So we can isolate our DMZ separately. So there will be any hard connection from between these VPCs. So through the
So is
private
it following a
gateway.
similar pattern like transit gateway, Ravi? That
No, transit gateway again, it is going to get connected. Multiple VPCs getting connected through the transit gateway.
right.
Again, it's coming with without transit gateway. Also with transit gateway, also we can achieve this. So they are coming with different architectures and deployment models. So in the next slide, we'll be having the transit gateway. Yeah, we'll move on to the next slide maybe.
Can't think of a colloquy where somebody says cloud is somebody else's computer, right? Think of this with Amazon having multiple patch panels on top of switches, on top of routers, on top of gateways. Can't
Yeah.
think of the architecture behind running behind this actually.
No, those are
Just
gone cases
click
now.
of a
No,
button.
you just forget about your whole data center. That's it. Don't
Yeah,
worry about your data center. Don't carry your cables and don't get into the loops.
Racks.
So the
yeah,
entire switching has already gone. Now routing also slowly taken out.
yeah,
Now
yeah.
again firewall and the security is also going slowly. Now ultimately every vendor is also trying to automate the whole thing. They want to get out of the appliances, and they are investing more time in terms of analytics and then same kind of solutions, so that we can collect more data from different places and we can apply our AI or ML algorithms and try to get to the exact point of issues. So the whole process is about skipping out of the devices and then the more number of switching and routing. Yeah, this transit gateway. So whatever you're asking, right? So when we connect multiple VPCs, again from VPC to VPC communication, we establish through the transit gateway. And within transit gateway, again, it's going to be a separate topic where we'll discuss about more on transit gateway and advanced VPC architecture, where the transit gateway will play a predominant role. With this current architecture, yes, you can push your traffic through the transit gateway to the GWLB itself. That is also possible. And inter VPC inspection is also possible. So that is what this slide is all about. And you can still so much of information to tell here. So you can refer that video, and once again we'll think, and if possible we'll try to have a separate video around this gateway load balancer and transit gateway, and how exactly the recent AWS introduction is the recent whatever the services they have introduced that is going to ultimately reduce your architectural size, and it will improve your way of deploying the whole instance and other connectivities. So the overall is simplicity is also there. So at a glance, yes, this gateway load balancer, it includes L3 gateway and L4 load balancer capabilities. And the endpoint is again, earlier we used to have the private link established to the NLB service. Similarly, gateway load balancer gateway load balancer endpoint is going to do that. Using the private link, you can reach out to the gateway load balancer. And it is going to be a horizontal scale to the appliances and fault tolerance and services transparently. You can inspect the traffic, and it is going to share across different VPCs and accounts. Since load balancer is gateway load balancer is going to be declared as a service, you can share it across multiple VPCs and accounts. So resource sharing will be enabled, and then you have to whitelist the principals. Once the principals are whitelisted, then your VPC endpoint will get connected to the gateway load balancer service. You have to accept and allow that connectivity. So this is a whole point about the gateway load balancer, and definitely go through this gateway load balancer. It's going to help your environment in a better way. So the troubleshooting time is ultimately going to reduce because of this.
Yeah, I'm sure this is going to be part of the Terraform and the cloud formation.
Yeah,
Imagine the
definitely,
world of removing the routers and switches to the gateway load balancer world where with a click of a button you have everything what you need.
Yeah.
I can understand Ravi's network background and how he's imagining the whole thing now.
Yeah, recently one of my friend has asked, like, the VPC reachability analyzer has been introduced. Since being a part of network engineer, you're saying, what is a big deal in that reachability analyzer? So it's going to check hop by hop. That's it, right? But when you think about the operational perspective, I'm not going to spend L1 and L2 task now. So the reachability analyzer is going to help you out there. So you can write
Exactly.
a simple script, just run this analysis and just come back. Is there any other issues in the path? Till my load balancer, or till my VPN gateway, or till my internet gateway. Ultimately, my first half an hour troubleshooting is getting reduced now. With a simple script, I'm going to test that analysis and come back with the result. So this is how whole AWS service is getting automated, and it is not a simple thing. Again, the use case is going to be much bigger what we think. It is going to ultimately reduce our operational timing and cost.
So actually, locating where the issue is more like 90% of your incident activity, right? When you are at your incident, when you are at fire, I think 90% is solved when you locate where the issue is. I think solving is mostly easy and we'll have help. But locating where the issue, finding the right people, putting in place, and then I think things will get solved automatically. In small bits like reachability analyzers, I know how much trace route has helped when we look for any hops about network, why my network is not connecting. Reachability analyzer, imagining it in the cloud, looking at all these route tables, security groups, looking at network routes, and then pinpointing where the issue is a dream. It should be it's going to help really resolving lots of issues, particularly these issues at network level. The lower you go in the OSI layer, I think it's difficult to locate and troubleshoot, either because of the expertise that we have around it, or also it's because of the complexity that is involved and things that are less human readable going down in the OSI layer. I think things like this is really welcome, and we have to see how we can put it into practice and then utilize it. This is very good, Ravi. I think we should have a separate session on reachability analyzer itself, even if it's a small one. I think it's going to really help. We should put some kind of a use case in place and then bring down some hops in between and see how we can find out manually and versus how we can find out using reachability analyzer. I think it's very important.
Yeah, we'll look at the skeleton level of the reachability analyzer, how exactly the hub of troubleshooting is, and what is the current supported troubleshooting around the reachability analyzer, and what is the upcoming expectation from AWS. Those things will get covered under reachability analyzer in a separate session. Please do subscribe and wait for our session. Maybe within a week, we'll have the detailed session around the VPC reachability analyzer. That is heavily going to help you out. No need to worry about the network troubleshooting in terms of connectivity. So that'll really help you a lot.
Love the way
Thanks a lot.
Ravi
We are
was,
coming to the end. Go ahead.
love the way Ravi was saying the with a single script you can see if the reachability is good or not, right? Applications when we create, it's more complex initial days, but maintenance of that application is forever. Once you feel this application which is already bringing revenue for the company has to be in a way that it is simplest way, can be operated by anybody in the operations world. If we get into that model, operations is forever. The more we make it more simpler is much better. You don't need a SME like a network guy to come and tell you what is going wrong, right? It can be with a single script, it can be traced easily, and then 90% of the problem is solved. 10% is only to figure out whether we have that problem. That's definitely a good point, Ravi.
Yeah, one good thing is AWS is not the one innovating things. They are pulling every customer to get into this innovated solution. You just innovate yourself, otherwise you will be in the last bench. That is what they are bringing in every reinvent sessions, and they are pulling our legs. Don't sit quiet and you will be lagged.
Yeah.
We have feedback from Darshan. He is congratulating us for the session, and he's also very interested to see the update on gateway load balancer. And as he's also interestingly sharing the network background, like Ravi. Thank you, Darshan, for being here. Subscribe and then be there with us so that we'll come up with much more specific sessions on networking as well.
Yeah, thank you, Darshan.
Ravi has someone who speaks his language.
Yeah. No, now there is no separate languages. It's only AWS. Now we have to get rid of the whole thing: network, security, compute. Everything is gone now. Now it's one single word is AWS. Get into the
I thought it
cloud.
was
I
Terraform
think
actually.
I think I see these two trends happening, right? These are like I forgot the word that is used in the movie Tenant. I know Rajesh is going to remember. Two forces, two directions moving around. What is it called?
It's a temporal pincer movement.
Temporal. Can you repeat that?
Temporal pincer movement.
Okay, I will leave it to what Rajesh mentioned. So it's that it's happening in two different directions. So the one I see is the shift left mindset, right? Whatever we are doing at operations level, security level, everything you want to move to the left side of your pipeline overall development methodology. So it's closer to the developers, so they can control everything and they can manage everything, so that they know what they are developing for and what it will be used for. What are the not just the business value of it, but also the infrastructure surrounding it, how this whole thing brings revenue to them, and what it means every lines of code that they are writing, right? The other trend that I'm looking at is moving everything towards the cloud. That is, even your data center, even things that you're running, even your routers. I'm sure one day I'm not going to have a router at my home. All I have is will be a cable, or I don't know how it's going to happen. I even saw some startups in Bangalore where they are using lasers to give fiber connections across home. So there is no more cable, just you have some kind of receiver on the top of your. So using lasers. So basically, if you have a way to view lasers, soon you will have this like sci-fi movies where they have these lasers passing through across in the sky, connecting each other's home, connecting data. I'm sure one day we will not have routers at our home. Everything will be cloud. CloudField is already there. I don't need my laptop. All I need is the internet connection with the browser. So I don't even need a Linux box or a Windows box to install and try everything. I think things are moving towards cloud. So one is the shift left, move everything towards developers. Other things move everything that you are maintaining yourself towards cloud. I think these are like two different forces that are acting together. I hope it will be a positive thing when this collides together, and I think everybody is moving towards colliding them together. We want our developers to take ownership. We also want our things to be running in cloud, managed services, that everybody can focus more on the functionalities, business values that we are providing, rather than juggling around with hardware or juggling around with things that are not an immediate value add to the customer, right? So that's really getting summed up with all the 3 weeks of AWS Reinvent. If you see, there are so many sessions that are conducted. If you try to put this together into this lift shift ideal and then moving towards cloud, it's all fits there somewhere in this overall graph. And then you'll see how they are getting connected. I think we should try to use the pieces that are interesting to us. Look at our videos, look at the patterns that we have discussed, look at all, as much as possible the sessions of AWS as well, and see what will work best. I think it's very interesting for us as a team here. We were able to go through different sessions again, parallelly looking at different horizontals, verticals, different domains. It could be new things in the reinvent. It could be the new things that are introduced in the reinvent, or it could be the sessions that are given by different organizations, people that are open to share their architectures and the pain points, best practices across. It was a great learning for me across this whole 3 weeks. And AWS is not ending it here. January already they have planned around 180 new sessions, because people are coming with all these new sessions because it's all virtual. We will see whether we can really cover that. But for us, AWS Reinvent 3 weeks is ending today. We'll probably come back with one more summary session around it so that we can have a quick recap of all the 3 weeks. But for now, this is the end of AWS Reinvent. Very thankful for people who are here watching live, and also for the people who will be watching offline, for supporting this overall initiative. I had a lot of learning going back in these sessions, and for everybody who has joined here along with me, discussing around Rajesh, Rafiq, Shiva, Ravi, spending their weekends. I know they are in different places right now, but still they were able to participate and then be here, sharing their knowledge. Otherwise, this wouldn't have happened. So, big thanks to everybody who is there live, for the people who are watching, and also for the people who are there sharing the screen with me. Thanks everyone. That's mine. That's from me.
One thing, just before we close, anybody wants to add anything? I can add something here.
I'm just thinking one funny thing about what Narayan said. It's about laser lights and pointing. I hope we don't end up with an era where we wear caps and have something like a pot on our head which receives signals and we connect our mobile devices there, right? So
You didn't order it yet? It's available on Amazon. Okay.
Also, I had one more point. Like, people started asking like how to deploy a third-party appliance or whatever on the EC2 still. I ask everyone to start installing it in the container. So already the vendors are started deploying their firewalls or whatever the third-party appliances into the containers. So get away from the EC2, get into the containers, and we had very good sessions around Kubernetes, and you can refer the Kubernetes analogy. That is like we used to always match with the generic meaning of the service words. For example, compute, or network, whatever the services we are bringing in, we always match the generic meaning first. So here we have a different types of analogies, and you can compare it, and you can learn it very quickly around what is Kubernetes and all those things. Definitely subscribe to Drive by Bytes, and you have very good sessions around Kubernetes and so many cloud technologies. Thank you.
talking about the same thing again, just wanted to recall one of my friends in LinkedIn by the name Pawan. He has asked a question about what would be the upcoming trends in 2021 about DevOps. Definitely a thread to watch out. And my take on the thread is it would be like more movement from containers to serverless.
Exactly. Yeah. The good example about the appliances on the cloud, like I explained, the simplest way to think about is the router that we have here. The router is just a small chip that is running there. What it does, it just marks your connection and then converts whatever you have and projects into Wi-Fi. So there is no point in having the small chip running here. It can be on cloud somewhere, right? But the only thing is that the hardware part of it, the way the signals are getting transferred. I'm sure people are going to figure out a way that signals are going to be automatically coming to your laptop just through internet, and then things will get solved. Uh, uh, there was an era where we used to have a separate box to convert your set-top boxes that converts your cable connections. Now televisions comes with those boxes. All you have to have your cable and connect directly to a television. I can imagine that laptops will have the routers inbuilt, and then all you have is just a cable coming out from somewhere and just plug it to your laptop, or generally receive it in your community somewhere and then use it. It's going to be there. It's going to be there. Trust me. I'm going to be there to see it.
I can trust you, Naren. We moved from an era where modem beep used to come from the laptop in the past. That's all to the Wi-Fi. Yeah, yeah, dial up to what we are using. Yeah, just to add one more thing, what we are seeing as a trend, right? And DevOps in the real terms is bringing the development and operations coming together. It's not meaning that they sit together, but the collaboration part of it, right? Today, the way network appliances can come into developer's hand, he can spin up a gateway and tell how is the architecture going to be. He can experiment that with a click of a button and tell what kind of an application can work. Then he doesn't need an operation guys to come and preach them how to build the components, right? He can write it in a way that he can write a Terraform and say that this is how it's going to come up, and someone needs to manage this one. So it's totally a very good collaboration. If we look from the real terms of AWS, the tooling and the things what's coming up is definitely something going to help the next generation of applications to come very quickly, innovate faster, fail fast, but people can quickly learn from the failures and can move on with the things. That's the overall ideology of DevOps world. And just to add to this, right, there's a lot of things which is there in the AWS. It's very hard for anybody to go deep dive, but look at the AWS restart. This is something made for anybody to learn the AWS. The way they also were projecting people who are unemployed, especially during pandemic situation. Don't sit back with the tools and technologies which we know it was good at that particular time, but if you have to move on, I think this is another good start to begin your career with. Get into the cloud world. AWS Restart is a good place for people unemployed. Start looking into the cloud world. There's so much of training added into it. You need to just have time versus anything else today. I think that's the one of the good challenge where learning with so many videos, it was never so easily available before. I think everything AWS made it free, which is a big kudos to the team making it so easy for the people, because sometimes you will not get a very good content. You might have a lot of training institutes and other things. The content is very important. I think the premium content they have added to the sessions freely. You can log in and learn from that. That's going to be a very good contribution for the women who wants to empower themselves, for the people who during pandemic got impacted, and anyone unemployed or any refugees also. That's one thing they mentioned. So yeah, it's a very good place to start your career with.
Yeah, it's an amazing initiative, Rafiq, but is it already available in India? India can, because no, AWS was sponsoring for the people unemployed. I read it like a few months back. I'm not sure it's already available in India for people to make use of free coaching from AWS around cloud for unemployed people.
Yes,
If,
they made it free in it already. You can log into the AWS. Yeah,
okay.
especially the certification part. They made it very easy.
Okay. Okay.
I
If no
think
other
people
last
in
word,
Chennai Tech Radar is somebody wanting to learn more about AWS. Please do sign up for AWS and learn a lot. And if you need anything specific sessions, we can again. There's another good forum of people here. A quorum. They can come and join us and talk about a specific topic if you need any more information.
yeah. Yeah, Shami is looking through trying to compare Matrix movie as our future, which
Yeah.
is right. I'm also following a recent series called Travelers, where people are coming from future and then trying to fix things in the past. Interesting if you want to follow. They have not shown the future yet, but they are showing that how people are behaving here, how they are able to move the consciousness via code. It's interesting. Watch it.
Waiting for the red pill yet.
So that's the last words are yeah, it's all amazing for having everyone here. This is a great event, lots of good event, and then we had a good content here, sharing our knowledge. People are also participating in this whole sessions that we had in the past. Thanks to everyone over here. Do forward the link and then be part of this community. We are trying to form an Indian community who is catching up with the tech, and then this has already grown up across other countries. I think in India, I think we should catch up. We should be in the trend, be part of it. That can only happen by being forming a community together, right? Like here, this is a very good example. Like as a person, each one of us wouldn't have covered all these sessions that we discussed in this particular video. I think it's just because we were together, we were able to cover all those breadth of sessions that we were able to discuss around. I think it's a good example of how community can help. So be part of a community, join us, join the channel. We also have a Discord group server where you can join and share. Keep this discussion going on. We have a separate channel for AWS, Kubernetes, Azure, etc. I will share the link also in the description. Be part of the community, join us, and then let's take India forward together. Thank you. Thanks for being here, and we are going offline. Thanks.
Thanks, guys.